Добрый день, уважаемые дамы и господа.
Hi, ladies and gentlemen. I am Dmitry Kuravin. I am team leader in charge of application security in Jet Infosystems, and I will tell you about our usage of secure development tools, about the problems we face, about cases we have, interesting and not very interesting anyway.
Итак, о чем доклад?
Now, what am I going to talk about? First of all, about the tools of SAS and SCA, it's their usage, obvious, non-obvious, different cases, and what do we have to pay attention to when you choose the tools for secure development? What kind of triggers you may have? How can you understand that the tool works in some special way? What are the peculiarities? What can be wrong? Whether it fits your environment or not? How can you evaluate the tools? SAST and SCA. So, at first, theory. We cannot do without it. First of all, you must understand what is SAST and SCA. Why do we need SAST? It's the search of vulnerabilities by templates, by source code, by signatures, how the data that we get from users, from external sources, move along the application, and what are the results. SCA is more trivial, collection of data about packets, and then we can map that information on the vulnerability base. The task of SCA is simpler. Nevertheless, it's important. What does the classical application consist of at a high level? 3 blocks. The first one is the source code developed by the people. Second, methods of external libraries. That's important. That's why we carry out component analysis. And point 3, methods of the libraries generated by developers in the company. This is the stumbling block very often in many instruments, including commercial ones, because for your own libraries, you will never find information about vulnerabilities, no feeds. It's your base, it's your product, and it's up to you to find the vulnerabilities. Then, how can SAST look for vulnerabilities? First, templates or signatures. SINGREP is a classical example of the tool of signature search. It has certain rules and constructs, and he looks through the code and analyzes it. There is no deep logic, there is no cause and effect analysis, just search by template. We analyze data, analyzes source code, analyzes methods and functions. Of course, there is semantic analysis. In real life, we never saw it, but it's one of the possible ways of analysis. It's the most complex analysis. I mean, semantic analysis, as well as tint analysis of infiltration. Application Spectre says they have such print analysis. Tint analysis is closest to OPSEC task. We have a task of taking the source code and use different methods and approaches to find vulnerabilities. What about SCA? It looks for packets, and the simplest way is to use manifest. There is a manifest inside the packet, and it shows what kind of versions of the packet the developer may use. The manifesto sometimes doesn't use the actual option. It may only indicate the initial version. And in the closed contour, your option can be different from the initial one. Second, it can use log files. So we collected log files, fixed the versions of the packets, and the SCA analyzer uses the log file and looks at dependencies. Dynamic resolve, it's a good result. We emulate the collector function, hot scoring, for example, code scoring. Code scoring uses the dynamic analysis function. And this is the right way to collect such information. Container scanning, also one of the methods, but apart from vulnerabilities in the application, we can get vulnerabilities of the basic image of the container and the final image that we get after the build. The basic image is not always equivalent to what we have after the build of the container of the application. There may be some upgrades, some additional packets can be installed, some changes in the binary code can be done. So container makes some corrections in the final picture.
Тезис номер один. Идеальный инструмент.
Important point one. Ideal tool is a myth. We talk about it on very rarely because we realize there can be no ideal tool. Each tool has its pros and contras, has its pluses and minuses, has its positive and negative things. You must understand what kind of languages or frameworks are analyzed or not analyzed by this tool, which tool is best for your environment. You must understand the tool. Second, the tool cannot replace your thinking. It's related to point one. If you want to evaluate a tool, you have to understand how the tool works. Why are we talking about it at all? We evaluate efficiency of the tool in our tools and in projects focused on implementation of that tool. We have Axenas colleagues who published a research. You can see a QR code. It occupies 10 or 11 pages. And they list facts which they considered important for security development, secure development. First, manipulation of vendors with the tests and benchmarks. Sometimes a vendor can say, well, our tool finds 100% of vulnerabilities. You launch it and see something quite different. Each tool is unique. Each tool is a unique mixture of solutions, codes, features, and functions, and something can go wrong. Do not always believe the vendor. Limitation of statistical analysis. When the vendor says, I can find 100% of vulnerability, understand that the more languages does the tool support, the higher is the probability that the total number will be average. You cannot efficiently scan script languages and compiled languages. Of course, each kind of language and framework has its peculiarities that you have to take into account. One language may have dozens of frameworks, each with its own syntax, connection, and for correct analysis, the tool must understand all that. In some cases, my colleagues believe after 87% of misses can be shown by the multi-language tools. A lot of false positives and a lot of workload on the team. The more false positives we have, the more workload you have for your OPSECs. And OPSECs will go to developers without looking that developers have a lot of tickets, there is a problem, and we don't understand what to do. And there is a bottleneck and a snowball. We have a lot of tickets, a lot of problems, but if we start dealing with them one by one, in reality, you may see that it is not a problem at all. It may so happen. It is not a vulnerability, it's something else. Then the black box method, it's also a problem. All those fuzzers and so on, they use certain template tests which do not take into account the context of applications and the methods of the applications. It's just a general purpose fuzzers. And the problem of integration. It often happens that when we implement commercial secure development tools, such tools block at integration, no matter how strange it may seem. It happens. Let's go deeper. How can we understand for ourselves? How can we understand that a certain tool is, that something is wrong there? First, suspicion one. The tool doesn't care about packets. You launch a scanner, and it doesn't ask for packet managers, for libraries. So the ready-made application is monolithic. It's the code and the methods of the libraries. They are all together. And if the scanner doesn't have any options for updating and tuning the packets, it means that it doesn't analyze them. Otherwise, the libraries would have been used. This is an example. We have an application. It's the general top-level scheme. We have an application and the user input, a sanitizer library, which is the enterprise library, and it is used. We have our own internal methods of protection, security methods, and we have the output, which the user gets as a result. And the structure of the library is on your right. If the scanner doesn't take into account library methods, it will go the following way. It will miss vulnerabilities, and if you have synthetic methods, you will have a lot of false positives. For example, we mitigate vulnerabilities, but if the scanner doesn't understand the libraries, it will miss quite a lot. Suspicion 2. The scanner demonstrates vulnerabilities by referring to any line or method. You cannot see where the data came from, how they move across the application, how the code is executed, which leads to the vulnerability. It means that the scanner uses templates. Take SYNCREP, classical application, on the left the signature, and on the right code of the application that we use for testing different tools. We want to find the call, which is highlighted here, or system comment injection. When user input gets into the application and leads to execution of some codes. And this is what happens in the test script. What will the tool find? Or system method inside the function. It correctly finds the imports, like in the first example, but we use the rename function here. We get a method and rename it. In Python, this is possible, and users often use it. Developers often use it in order not to write long names. I use this method myself very often. SyncRep understands it. And, for example, there are commercial tools which do not understand this trick. If you use rename, then application inspector will understand it. Some other tools will not. One more thing is interesting. Same functions as we saw in lines 8 and 11, but we address to the object by name. It's important to see what kind of globals and locals in Python the tool can understand. If developers like such methods of addressing the objects by name, in stat analysis we are not going to see that. It's one of the limitations. There is a third point, which is about the condition. In this case, in SyncRep, doesn't understand the context. It takes the variable, its value, compare it, and take a decision whether to execute the function or not. Stat analysis doesn't have a mechanism. SyncRep doesn't have a mechanism which can evaluate whether the environment matches this parameter. For secure development of commercial applications, the scanner doesn't have information about what kind of environment will exist in the production environment, and you will have a lot of false positives because it cannot understand the context. That's why suspicion 3, no context, no understanding of the context. It's important, actually. Why? Because of what I said, and we have such cases when SAS and SCA try to evaluate application. It may so happen. If the application is in ACD, there is no problem in delivery of those variables. Versions of the packets are delivered as variables. Automatically, we enter the values from CI/CD and collected without problem. But if it's inside the scanner, or if we try to collect it locally, all those variables should be on the host. Otherwise, the process of collection that the developers had in their minds will not be executed. We'll get an error, or sometimes commercial tools do not see that you didn't collect anything and they do nothing about it. For a scanner, it may be a problem. Another example, when variable environments are like this. In line 6, you'll see the environment through CI/CD, and it's not a secret. We expect it. We add a variable, but scanners may correctly process it, or they may say it looks like a secret. Take, for example, this screener. It will correctly see that there is a secret inside and misses CI/CD variable here. The scanner understands the context and believes that it matches that what is to be done. Suspicion 4, a bit of magic. It's a deep question which requires research. Vendors often doesn't tell you about the methods they use to find vulnerability. They may say it's a commercial secret, it's in-house developments and so on. But for OPSEC, it's important to understand how the scanner looks for vulnerabilities. The scanner, in this case, is just an automation of our routine actions. We can find the vulnerabilities manually, but sometimes we delegate it to the tool. We write the rule, launch the scanner, so our eyes relax, and we get the result quickly. But sometimes the vendor says, our scanner will find everything, and we don't understand what is he going to find. And this is a problem. Unfortunately, we have example for open source only, which are open. In these tools, you can understand what kind of rules are there and what kind of libraries are taken into account by the scanner. What are the sources? What are the codes, code QL? In SAS analysis, for example, here it's a Java application. If we take a list of libraries and this table, and we can see the coverage of the scanner and understand which parts of the code will be scanned and understood and which will be missed. And those which are not in the table will not be analyzed by the scanner because he will not understand it. And classical problem, suspicion 5, most of the tools have it. Unfortunately, technical support doesn't use the tool, and you have to support the tool yourself on your own. And now let's move to the second part of the presentation. How do we test the scanners, and what do we pay attention to? First, what do we test? Methods of analysis. It's not as important what the scanner will find at first iteration, but how it is going to find it. Signatures and so on. We'll launch it for the first time. The scanner runs. We scanned and got a certain result. This result means nothing before we understand how did the scanner found those vulnerabilities. What was the logic of the scanner? Why did he decide that this is a vulnerability? Then we're going to realize whether it uses templates or methods or graphs or data flows. It's important to understand all that. Second, customization and usability. The engine. You can develop rules, and that is important. The rules are the main requirement to security tools. If the tool doesn't allow you to write the rules, or if the process is very complex, then the tool is bad, because you will find only the vulnerabilities that the vendor indicated beforehand. And for secure development, you are automatically linked to the vendor, and you will require continuous updates, and the vendor cannot guarantee that it will find everything. Closed circuits we told about it, but this is a serious problem for some tools. When suddenly it turns out that the tool works in a bad way with LDAP, commercial tool, large vendors, but the tool cannot send letters, is SMTP. And we often find abilities within the scanners themselves. What do we expect from SAST analysis? We have certain applications, and on your right, you can see the methods used in the libraries which the developer inherits for the code. And the results of those methods go back to the application code, and we expect that the scanner will go that way, but it will not search directly in those libraries. Well, you can take a project, you can take the project, send it to the scan, and find 10,000 vulnerabilities. Do we need them? No, because there is no entry point for end user data here, because it's vendor volume, and less than 1% of that code is used in our applications. All the rest is false positives. But if you get 10,000 vulnerabilities, you will overload your scanner, and it will be large workload on your OPSEC people, although you can avoid it. Search for secrets. It's a script that we use for secret search. There is a certain secret here which most of the commercial tools cannot find. But in Python, it's quite natural. Application inspect understands it and finds it, but AppScreener doesn't. There are methods of search find for the upper line, and in line 12 we also have entropy. Inside I developed a script, and sometimes we use it, and by entropy you can confirm the correctness of secret search. We can recheck it, and automatically through entropy confirm it. Customization of rules. TrueFillHop uses it. What do we expect from customization? Exclusion or deletion of the rules. Unfortunately, we have it only in one tool, but although it's an important feature, because vendor rules sometimes produce a lot of falses. SAST analysis, you know, how many vulnerabilities it shows, which means nothing for you, which are not about your application code. And accordingly, it's important to switch off, turn off the rules. Well, you have to point out that you must have the capability to turn off the vendor-based rules and create your own rules. Sometimes you can write it directly in the scanner, or develop it somewhere out of the scanner and then upload it. It's a better way that if you can write it inside the scanner itself. And there is a third option when you can write the rule inside the tool and check it inside the tool and debug it. Unfortunately, no commercial tools have such a capabilities, debugging. Yes, debugging. Do we have to use special utilities, or can you do it in the scanner as is? If you have the rule generation feature and you have to run scanning for secure design, you will overload your tool. The developers can have pipelines in CI/CD. Even in CI/CD, you need 2 or 3 minutes. If you have 10 iterations, pauses, lags, and the simple thing can take a lot of time.
Ну и выдаст какой-то результат.
Mhm.
Ну и безопасность.
Well, and security. Is there foolproof capability?
То есть,
And you have security. The scanner itself is foolproof. We made it crash with regular expressions, for example. We had ReDOS, other such classical vulnerabilities, and scanners just go on an infinite loop.
Он может быть там, ну, грубо говоря, молодым специалистом.
Rule developer can be a junior. They might be inexperienced, they might be testing something out.
Он напишет такое правило, которое...
So if they have a rule that crashes the scanner, it'll go haywire. And the tool will not be usable commercially.
Мы там находим различные уязвимости.
Vulnerabilities themselves.
Ну, здесь такие там одни из
We report them to vendors.
самых прикольных, которые мы находили за последнее время.
These are
Вот. Но важно отметить,
the
что
most fun ones out of those that we've identified recently. Vendors reply often that they don't have vulnerabilities.
эти сканеры недоступны для большинства исследователей. То есть, ну,
The scanners are not available to most researchers. That's one of the reasons.
они есть в публичном доступе. Соответственно, чем меньше исследователей,
Vendors don't have them in their bug bounty. They're not publicly available.
во-вторых, не все
That's
могут позволить себе
logical
рабочие
that
инструменты. То есть, если у вас
you don't have reports if it's not out there. Then if it's a secure development tool, you cannot always start hacking it or crashing it because there are other people who use it. And then some vendors do not know where to apply the load to find the vulnerabilities.
Но это вот
Some of you might have seen this phase.
конца прошлого года, начала этого года.
That's what we've been testing late last year, early this year. His name is Alex Burson. He found a vulnerability that
И с недавнего времени мы на коммерческом
is
тоже проверяем такие
out there in the supply chain. It's a type of attack that we've been checking frequently.
Очень часто бывает, что
Here is the model for this attack.
там, допустим, говорят, вот у нас есть какой-то недоверенный,
Some companies
надо проверить. Ну, типа, что мы делаем?
execute-
Берем и засовываем его в SAS-анализатор.
wants to execute untrusted code. If it is run through a SAST analyzer, the scanner installs the packages. There is a malware script in the package, and then there is RCE in the scanner or its module.
Ну и, собственно говоря, вот
There was an example from Python. Here is how it
вот
looks.
буквально там в начале года мы нашли в двух коммерческих инструментах.
Earlier this year, we found such vulnerabilities into
Поработал над исправлением.
commercial tools. One vendor accepted it and fixed it.
Это
The other vendor told us that it's not a vulnerability,
ожидаемое последствие. Вот как здесь написано.
but an expected consequence, as they phrased it.
Как бы, если пользователь сканирует недоверенный код,
They claim that if you use untrusted code in
если вендор открыто не
the
заявляет
scanner,
о том, что
it's your problem.
предназначен для поиска НДВ, то нужно быть готовым к тому, что сканер сам
If
может стать жертвой при таком
the
сканировании.
scanner doesn't say expressly that
Что
it can be used for untrusted code, it can become a source of malware.
других приложений, которые вы сканировали.
And then this can compromise the source code of other apps that you've scanned,
Вот, поэтому
because
тоже к этому надо быть готовым.
there is a lot of data within the scanner.
Ну, самый первый — это критическая оценка. То есть
On to
нужно
conclusions.
критически относиться к тому,
Take a critical look
что говорит нам вендор. То есть,
at what you get
всегда лучше
from the vendor
проверить. И проверить на своих
Double check.
приложениях, когда вы знаете уже какие-то заложенные
and check it
уязвимости,
against your own
вы понимаете, что
apps
там
where you know
уязвимости были
the
обнаружены,
vulnerabilities.
пофикшены,
where you know that they've been fixed. This would be a sort of safe independent test. Heat maps. That's what I've described, and the vendors offer it. If you start doing this, you'll see that most of the apps that you scan are a sort of uncharted territory for apps. Not a single scanner accounts for methods in the libraries that are added or pulled by the source code of the app. You can bypass it. We had dynamic addition of the libraries where we presented them as part of the source code. You can export the code from there, add it to the source code, rewrite it dynamically, and then application inspector and other scanners would be able to catch it. But if it's in libraries, no, this doesn't work. All these methods require additional development. It'll depend on the framework, on the programming language, and the willingness of your OPSEC engineer to do this development. Your best test is the one where you wrote the rules. It's not my claim even. It was said by check marks from the times when they were used to be present in Russia. This holds true. If you run check marks in any simple project, there aren't going to be that many vulnerabilities. It'll flag some vulnerabilities according to the rules under the hood. The scanner is not bad. The reasons can be different. Lack of rules is one. Then the methods that are used for scanning is another cause. The analysis might have not reached the parts of the code where you have vulnerabilities. And then libraries again. If these are third-party libraries, the scanners do not see them, which creates major gaps. The best OPSEC engineer is the one who knows what's under the hood in their scanner. Thank you, colleagues. That's it from me. I'll be taking questions now. Microphones in the aisles. Yes, do come up and ask your questions. The best question will be rewarded with a book from Teacher Publishing House. Pavel Orlov, T-Bank, thank you for the presentation. You said, when you spoke about secrets, that you use entropy to filter out false positives. Why not use GetLeaks, which has it out of the box? Truffle, GetLeaks have different applications as tools. GetLeaks has history lookup as well for past commits. If you're looking for vulnerabilities online, you have source code and you get a result. Then you need to verify it automatically for secrets. Then truffle or entropy checks will get you there quickly. GetLeaks is for a slower pace. You have a repository, for example, and you need to clean it up. There might have been a commit, then there is recommit, and it's in the commit. When they saw that there was a secret, that's where you'd be using GetLeaks. As an integrator, we do deploy tools, but we have contracts to analyze code, to do code review. Different apps, different projects. We need to do this on the go. So I've focused on the methods for online. It's about labor intensity, yes? Yes. So you are not looking for secrets, and if they were fixed, it can be an expert or a Git repository.
Дмитрий, спасибо большое за доклад. Было
Thank you, Dmitry, for this presentation. It was very interesting. My name is Georgy.
Хочется услышать ваше мнение на стыке двух смежных.
What's your opinion
Это вы сказали,
at
что
the interface of two
анализирует исходные
subjects?
логи и анализирует различные вызовы библиотечные, внутренние.
You qualified a good analyzer as
И при всем
the one that does calls and analyzes them transitively. And then you mentioned rules that can be customized and tested. It begs the question, how do you test custom rules without running a full scan of transitive functions so that it doesn't affect CRI, CD, and the full scans of all projects?
Вопрос хороший, на самом деле, да.
A good question, yes.
Что есть разные типы правил для разного.
You have to understand that there are different types of rules for different vulnerabilities.
Application inspector, да, там вроде типа проще.
Let's look at Application Inspector.
То есть там есть метод поиска
Template
по шаблонам.
scan.
Вы в рамках поиска по шаблону
It's a method there
написать шаблон для поиска
where you can set up your own template for vulnerabilities like mgram. And then there are SAST rules. They are under the hood in the scan,
В последних версиях там больше нет.
but they don't let you write the rules in the recent versions.
Не можете такие сложные правила написать, которые будут.
So you don't have to run a full scan.
То есть для того, чтобы проверить работу шаблона, вам достаточно одного правила.
You cannot write these
Имеющихся на сегодняшний день
complex rules. So to check one template, you have just one. You have just one rule. Okay. And what if you write rules for data flow, other more complex
Тут, в
things?
принципе, нам достаточно вот одного просто какого-то кастомизированного микроядра.
Yes,
Ну, сканера.
you'd need just one microkernel from the scanner, which is customized.
Правила на одном проекте. То есть
You
нам
run just one rule for one project. You don't have to initiate a full scan. You just initiate that one rule.
намного меньше времени,
It'll
чем
take
запуск полноценного сканера.
much less time than a full scan, even if it's at an entire project. Okay, to follow up on this, what if there are dependencies between rules?
Если написано свежее правило, зависит от.
If a new rule
Вы сейчас имеете в
is
виду
dependent on some other rule, do you mean something like CodeQL? Including that, yes. Or if
Сработает другое правило. То есть какие
application of the new rule depends on the output from the previous rule. Yes, you'll have to run a full scan, yes.
изначально обладает сканер. То есть если он
It's down to the original capabilities of the scans. If it's just running the templates, you don't need a full scan.
если там более сложные методы анализа, то понятно,
If
что
the methods for analysis are more complex,
правила запустить на всем проекте. И,
you'll see that you'll have to apply the rule to the entire project.
соответственно, придется запускать полное сканирование.
You're right. It'll require a full scan.
Спасибо за доклад. Меня зовут Илья.
Thank you for the presentation. My name is Ilya.
Сейчас все больше сканеров статических
My question is this.
добавляют к себе
There are more and more
функцию. У кого был
static scanners.
Вот в новом
We used to have SCA.
выкатила функцию проверка компонентов на использование уязвимой
They
функции.
add
Таким образом,
components for calling
практика
vulnerable
пропадет, и вообще под проблемой
functions.
SAST мы будем делать ESA.
It seems to
Как ты
hint
считаешь, можно
that
полностью съесть
SAST
практику ESA
will
SAST-ом? Нет, да?
fully replace SCA as one of its new parts.
Там же все построено на
Your example with TIE
на той базе фидов, которую предоставляет.
relies on the feed
Ну, вот
base
важно понимать,
that you
когда мы
get
проводим
from the vendor.
анализ, ни один SCA
When you do
анализатор,
component analysis,
то мы, типа,
not a single SCA
используем
analyzer
метод какой-то в коде. То есть он говорит о том,
will
что у нас просто
show vulnerable methods in the code.
он, ну,
It has a graph of calls, and it's reachable
те библиотеки, которые имеют известные уязвимости.
because it calls libraries with known vulnerabilities.
Реально методы из кода, как
But it doesn't mean that
эти уязвимые методы.
data from the
Просто подтвердить
code
гипотезу о том, что
invokes these vulnerable methods.
по дереву вот, библиотек, которые мы там, ну,
You'll have to
активным
then validate that hypothesis
как-то касаемся вот этих уязвимых
that
функций.
through transitive dependencies you'd be invoking
Вопрос,
vulnerable functions. But there is no tool that will say if it affects you. You'd need a diff from the vulnerable version, then the fixed version,
верхнеуровнево, то есть понять, в каком
And then
класса там метода
you'll need to understand where the vulnerability is, if it was fixed.
вызовов упирается вот в этот регион исправления, тогда мы можем хотя бы хоть как-то
If your calls go to the fixed
скорее всего, мы
area of the code,
затрагиваем своим
then you can say with some probability that
Но вот это уже другие методы
your
анализа.
code calls to the vulnerable part. But why would you need this information
Абсолютно верно. Ну, то
if
есть,
you use
как бы,
the vulnerable component if you do not call the method?
все понимают, что
You're right in saying this. It's a common challenge. Everybody knows that SCA is needed, but nobody knows what to do with its output. We have information about transitive dependencies with libraries that lead to vulnerabilities. But then you have this on level 2, 3, and 4.
Более того,
This doesn't mean by default that the code will be affected by these vulnerabilities. If you have your own app and then it inherits components from some third-party thing, that's one case. Unlike your own library that you're developing that inherits some vulnerabilities.
в рамках Quality Git мы должны, получается,
As you're doing
эти уязвимости.
quality Git, you'll need to go a level higher.
Ну, то есть у нас есть приложение.
If it's our library, well, we have an app,
нашей, и у этой библиотеки
it uses our own app, and then that library
это транзитивная зависимость и уязвимость.
has a vulnerability.
Принципу, что мы скипаем все, что
It's transitive dependency, but if our quality gate skips everything that's transitive, we'll misdirect vulnerabilities in our own libraries. That is something to keep in mind as well.
такого подхода, что, во-первых, если это каста,
Our approach is this.
все, что на первом уровне вложенности, это однозначно уязвимости, мы это
First level of embedding in custom libraries are
ну, open-source какие-то.
vulnerabilities, if flagged as such, and we fix them. If these are open source, we don't usually go, or it's reachable, if it's to the third level down. On probability, you can just accept it as a risk. Another question about SAST. You mentioned writing your own rules as a criterion. It's a mature approach, very much so. Not all OPSEC teams can afford writing their own rules, which then means that teams have to procure expertise from the outside. And many vendors have trained their tools on most common projects. I come up with my own vulnerabilities and then test my scanners on what I feed it, not what was used for training. And open source sometimes is even better, like SimGrab. Do I have to report it to the vendor, in your view, my own vulnerabilities that their scanners don't find? Or just tell them that you're not up to our standards yet? Well, the rules are not confidential, so you can share, but this would be you doing the vendor's job. It's a question if you'll be willing to do that. We engage with the vendors a lot, and I try to push them towards opening open source rule marketplaces, contributed by users, tested by each other, exchange of rules. This would drive detection, and you'd be able to skip bad rules if they're voted down. But if I tell them that here is the code that your scanner didn't find, they'd write the rule and they'll fix it, and it'll be more expensive. Yeah, now it detects them. It's a well-known issue. But it's a philosophical question of what to do about it. You need to first determine what the problem is. If it's about the rule, it's easy to fix. Sometimes the scanners do not go to the parts of the code that you wanted to. Hello, thank you for sharing. My name is Alexander. You said that you have a set of tests to see if an analyzer has different methods, aliases and other. Static analyzers are being tested now. AppScreener is part of it. FT is part of it. And they have an open set of tests for analyzers. It's published under GPL v2. So are you going to upload your rules there as well? Well, I think so. I don't know where to. I'll send you a link. Sure. There isn't anything confidential. We use the methods that scanners do not catch. Our system is easy. It's not about coming up with some code that the scanner detects. It's about edge cases. If it uses globals, for example, the scanner doesn't know. Yeah, sure, will do.
Дмитрий, спасибо большое за доклад, было очень интересно.
Thank you, Dmitry. That was very interesting. You had a slide about CVEs, and then you had vendors. What's the quickest way to detect a vulnerability? Like, I'll take this scanner and it'll be 10 minutes or 1 hour detecting NRCE. What was the case where you did it the fastest? What was the fastest case? We had the license expired, we had to renew it, and it had a license download without an account. And the vulnerability was in that you could get XXE for that handle. It didn't decompile for them correctly. We put a payload there, and in this licensing module in a commercial scanner, there was a vulnerability. They fixed it, of course. Thank you for the presentation. Here is my question. There is all this ML hype. You get different ideas about integrating it with SAST analyzers. Does this make any sense, especially as you're talking about custom rules? People can have different approaches to writing styles, and different products would require different rules. Could you clarify? Let's say we have a SAST. You can write custom rules. And then we have the products that we'll be analyzing. And it could be preferable to customize the rules for each type of the product. Similar checks can be expressed differently. So there are going to be differences in style and syntax. If you configure them dynamically, you could get better detection. Is it useful? Unique sets for specific apps. Let's call it that, yeah. It is possible only with SIMRAP, where you'd have templates. I don't think you'd be customizing CodeQL. Ideally, you'd combine these two. Speaking about open source, commercial scanners would not give you this functionality. AppScreener lets you add and remove rules. If your app is published with reverse proxy, so SSL or HTTPS detects can be discarded because you have reverse proxy. They become invalid as alerts. You can customize the rules set. And then if you speak about the rules themselves, this is something that you can do, but I'd use CodeQL and mgrab or OpenGrab. You see, the challenge is that you'd have to do this for each app. So we have different customers, especially in your case. all customers would each have their own guidelines for code development. If you could tailor your scanners to this, performance would be better.
На тоненького, я понимаю.
You know, it requires a certain balance. You can decompose the task and make the rules as simple as possible. If variable is present in the code, then you have a hard-coded secret. You wouldn't have any false positives, but there is no guarantee that today it's called secret password and tomorrow it's secret password 2, secret password 1, and then the rule will fail. So it takes away from the flexibility. Hello. I almost forgot my question by this point while I was queuing up. What's the actual, main thrust of this presentation? Your conclusion is that we have to customize the rules, but you always do this at some rate. It's about the skill set that's required. Assessed Analyzer is a very straightforward tool, and it's not aware of the context. So it's down to the business logic and how they translate into the rules. To follow up on the previous question, why not use AI? As was presented previously, AI can be used to generate rules if you don't have the skills. Because, can you recap your presentation? Because what I took away is that analyzers are pretty much useless. Well, no, they're not all useless. They all have their own limitations, and you need to be aware of those. Oftentimes, it has to do with lack of rules, specific rules. When we go on to write our own rules, if you try to do this for SimGrab or Application Inspector, PVS Stereo, and SolarApp Screener, you'll see that the process is entirely different. If you did this for App Screener, you've seen it all. It's very unorthodox, and it's different vendor to vendor. There is no standard. So it's preferable to know this in advance. Once you buy and implement something, are you willing to customize it? But we'll have to learn to do this, and we'll have to learn the syntax. Yeah, but not all vendors let you do this. It's a different question. In Inspector, you can use DSL, what they call them. But 3 or 4 versions before, they don't have set rules. The button is still in the UI for 0.11. The new version doesn't let you set the rules. It's been taken out. So you have templates, that's all. But I don't think it's any useful without custom rules. Our goals can be different. What if we want to look for profane comments in the code? It's not an out-of-the-box functionality, but it's a custom rule that we might need. That disqualifies the tool in procurement. Well, we are on the same page there, but it's not out in the market. The customers do not ask for this. Until it's not required of the vendor, they see their job as developing a scanner that takes the code and spits out some results. OPSEC usage, developer usage is not considered. The end user of assessed analysis is the developer. OPSEC professionals use this, but it then goes down to developers to fix it, actually. So that's the end user. As long as nobody requires this of the vendor, well, we are constantly asked to provide this. For 3 years, I haven't had a negotiation where people wouldn't ask about custom rules. And I think that the room here is all competent. Yes, but the rules can be different. In 2022, for example, what scanner became the most popular? We don't have check marks. we don't have access to Snake, other foreign solutions. Everybody went for SimGrab. They have scient analysis, but you cannot use this from the console. You have to be connected to the cloud. That's their current policy. It's not free. You can write rules, but they will not run in the free version. It's not the problem. We could get Russian vendors to do this, but not all vendors are willing to open rules creation and test analysis. No, it's not available.
Можно, значит, наверное, можно написать.
Ну вот смотрите, взять готовый.
Well, look, if we take a ready-made product, I'm not ready. Well, sorry. We can shift this discussion offline, off stage. Let's listen to the last two questions because it's an interesting discussion and you can continue it later. Hi. Well, first of all, thank you for the presentation. And the question is like this. On the one hand, a user of SAST wants customized rules. On the other hand, it doesn't want to do something wrong in doing that or significantly increase the time of analysis. Who should be responsible for that? And what is the difference between customization and over-customization? The vendor assumes the responsibility on itself, because when the scanner drops, when it is crashed, you go to the vendor. If you in Windows open the Windows and everything is crashed, it's the problem of Windows, not a problem of user. Maybe a user does something wrong, uses a wrong name and everything crashes. It's not a problem of a user. If a user can do it, if it has such a capability, then the vendor must assume that that a user can make mistakes. In Windows, if you use the site Windows 101, it always highlights in red how many iterations were used, how much time was used. You can have a regulator or a bad regulator, but the scanner will consume it. And you will have unlimited, infinite scanning, and you will never understand where the problem is. Because logs are also a big problem. There is no transparent mechanism for log collections, and vendors do not think that an OPSEC cannot always come to the host and take the logs, because they don't have access to the host on average. And very often OPSECs cannot go to the host and take logs. But the vendors do not think about it, and accordingly, a problem with crashes, well, you will never understand why, because the tool is not ready. It so happens that you would like the vendor not only provide the maximum customization capabilities, but help you to write the rules and correct the errors and point out the potential errors. That would be nice. The open marketplace of rules would be nice. If we eliminate competition between the vendors, that would be good. Because the vendors said, okay, I did it, and nobody else should know how I did it. If we omit it, if we install, if we develop a common standard for rules, that would be good. Then we can prioritize the rules, divide the good from the bad. The good ones will be voted for, will be published in the marketplace. So there should be something like a play market for such rules, where users of SAST and OPSEC can choose the rules, pay for them or choose them, and the vendors will see the popularity and the efficiency of the rules. Thank you very much. I got the answer. It was a good answer. Thank you very much indeed. Hi. Let's talk not about vendors, but about users and developers. Using SAST out of the box is impossible because you will have a lot of falses, paid, unpaid SAST tools. The developer doesn't want to develop rules. The developer doesn't want vulnerabilities in his code. Yesterday, we heard that this is a problem which is not being solved at the moment. It's a problem of the program verification. So the problem can be solved by heuristics, and the rules, sets of rules, are actually heuristics. And for the here it is a set of use cases collected here and there. And the question is like this: how can we find the golden middle? OPSEC development is needed. On the other hand, it's a workload on the team, and teams are different. You can have a senior-based team and junior-based teams, and they will start developing it and will make the things worse. So what are your ideas about how to install this and what to do with the information that we get? Good question. Look, everything starts with what? When we launch scanning, the scanner gives us the result. What do we see there? Description of the problem and recommendations. If you take the average tools, descriptions and recommendations, you will see nothing useful, which is not related to practical life. If you have, well, SOC solutions, Russian-based, Russian-developed solutions integrated with AI assistants, if you launch our descriptions, then most of the models will try to fix your codes and offer a solution. But this is for open circuits. With the closed circuits, well, we can launch the model inside the enterprise. 32 billion models. We have open source, free models. Of course, we have additional risks related to the AI assistant, but, well, for young developers, for juniors, if the code is not closed, you can, you can download the description and ask for corrections. If we have complex vulnerabilities depending on different methods, then AI assistant wouldn't analyze the context. We have black box AI solutions, integration through plugin, but you have to send your source code somewhere. Not all the people would like to do that. Especially in enterprise solutions, not all the companies can allow that. So there are banks and government agencies, they cannot send their source code elsewhere out of their perimeter, but local models can be done. Build the right recommendations for the developers. I told you before that what is the problem? Vendors generate tools. The tools finds vulnerabilities and gives you recommendations, but the end user is not the OPSEC. For example, when I look the result, I don't need the what is RCE, I understand that, but what about the developer? Does he understand that? How can we explain it to the developer? How can we teach the developer? Then, of course, when we write reports, sometimes we attach the codes with corrections. The problem is clear. Something was done in the wrong way, and you can easily rewrite it. Why not doing this? Why not attaching this code? If there is no functionality, then you can add an example. Of course, it's difficult to do it for the whole project. If there is something fundamental, the violation of the role model, you have to redo the application on a large scale. Well, may I add, because we don't have enough time, answer me yes or no. Can we tune SAST in such a way that it will not give us false positives? Well, upscreen. Yes or no? Yes, we can. SAST or you can reprocess the results. SAST results. Thank you. I know why you close the section.
Но это еще не все. Тебе нужно вспомнить.
But this is not all. You have to recall all the questions and choose the best one. That one over there. Well, please come to the podium and get the prize. Thank you very much. That's all. Thank you.
И мы на этом завершаем. Спасибо всем.
And at this point, I can say goodbye to all of you.